Hello, my name is Brahim Benhamou from Cadi, Ayyad University of Marrakech. This presentation is about passive ground air cooling for low energy buildings with a case study in Marrakech. The outline of the presentation is as follows. So what is the motivation of this study? It is well known that the need for more indoor thermal comfort combined with climate change should affect the building design approach. To this end, many traditional and new passive cooling techniques are widely used. However, the main inconvenience of most of these passive cooling solutions is their dependency on the local climate to operate efficiently, leading to cooling effects that are dependent on the heat wave duration. However, the use of the ground below a non-insulated slab-on-grade floor as a heat sink does not lead to have this drawback. So how to use the ground as a heat sink for indoor air cooling? This may be achieved by either direct or indirect contact. Direct contact is represented here by the buried house or the house built on slab-on-grade. The indirect contact may be achieved using this system, the earth-to-air heat exchanger, which is constituted by the buried pipe and the outdoor air is getting cooled through this pipe. How direct ground cooling works? This is a schematic diagram of a slab-on-ground, which is a slab which is directly laid on the earth to support walls and other structural elements. It is either called slab-on-grade or slab-on-ground. So let's now move to the experimental study. In this experimental study, the slab-on-grade surface temperature of a house located in Marrakech is monitored. Measurements are still running since May 2015. The walls and the roof of the house are well insulated, and the experimental setup includes a temperature slope and a data logger that measures the house's slab-on-ground surface temperature each 1 hour, far from the building's edge, at least 5 meters from these edges. And also temperature probes and a data acquisition system that measure the underground temperature in the house garden at 6 different depths. These measurements are recorded each hour. Also, a weather station is installed close to the measurement sites to record all local meteo data. These are some photos of the experimental setup and the building, the monitored building. You can see the data logger for the temperature measurement and the weather station. Here you can see a photo of the underground temperature monitoring setup constituted by 6 probes. Here are some results. These are the results of the monitoring of the slab-on-ground surface temperature over 2 2.5 years, we can see here that this temperature, the slab-on-ground surface temperature, is in between 18 degrees C and 28 degrees C, while the outside air temperature is evolutes between 5 and 45 degrees C. Here we focus on summertime, 2015 summertime, and these are also the monitoring results of the slab-on-ground temperature represented by the red line. The blue line corresponds to the outdoor air temperature, which oscillates between 18 degrees C and 45 degrees C. At the same time, the slab-on-ground temperature is in between 25 and 27 degrees C. Now, what are the main outputs from this case? In this figure, a diagram of the frequencies of the recorded slab-on-ground temperatures are represented. Here we can see that these temperatures over the more than 4 years monitoring are in between 19 and 26 degrees C for around 85% of the time. In this figure, we represent the correlation of the slab-on-ground surface temperature and the underground temperature at a given depth. It was shown that the best correlation is obtained for this depth, which is represented here, 1.6. It's 1.6 meter, yes, and the correlation is represented there by this formula. So we can deduce from this result that the isotherms beneath the slab-on-grade temperature, the slab-on-grade of the house, can be schematically represented as in these two figures, in the summertime and the wintertime. We can see here the benefits of the ground for the building, either in summer and in winter. However, at the edges of the buildings, there is some undesirable heat transfer, which can be stopped by a lateral thermal insulation of the foundation of the house. So what are the concluding remarks of this? The main conclusions of this study, which I reminded is valid for continental hot climates such as in Marrakech. So the first conclusion is that considering a set cooling temperature of 26 degrees C, the non-insulated slab-on-grade floor contributes to cool down the indoor air for more than 89% of the summertime. Also, the beneficial effect of the non-insulated slab-on-grade floor is present in winter time, as this floor contributes to heat up the indoor air for more than 86% of the time, considering a set heating temperature of 19 degrees C. Furthermore, to limit the undesired lateral heat transfer throughout the slab-on-grade, it is recommended to insulate the lateral building's foundation over the 50 centimeter depths. So that's all. I am now ready for your questions, if there are any. Thank you.